Today we are talking about solving one-step equations. When we do, we must use the inverse operation, show cancellations, box our solution, substitute for a variable, and prove that it works with a check. I'm going to show you how this works with a different equation than what I have here, just so we have a good intro one. Let's say we start with x plus 491 equals 562. I have to get x by itself, which means I have to get rid of what's with the x. So I'm going to do the opposite or the inverse of add, which means subtract. If you don't remember or know what inverses are, they are opposites. The opposite of add is subtract. The opposite of multiply is divide, and vice versa. When I do this to this side of the equation, I must also do it to this side of the equation, or it will not remain in balance. These cancel. That is our cancellations that we must show with one line through each. Then we're going to move the x over, bring down the equals, and solve our problem, but we're going to solve it out to the side. This area here is not for our borrowing, our carrying, or our dividing and multiplying. It is for just our one-step equation. It's like sacred space. So this is going to take some borrowing. So I'm going to borrow from the 6 and make it a 5. This becomes, no, that's not true. I don't have to do that. 2 minus 1 is 1. Now I got to borrow from the 5, make it a 4. This becomes a 16. That's 7, and this will be 0. So x will equal 71. Box our answer, and that is where box your solution is. Now we must substitute and check, which is our last two steps, meaning you have to put this in, the 71 in for x, and see if it really does work. So I'm going to write this whole equation all over again, except instead of this being x, we're going to call it 71, and we're going to see if that works. So we're going to say 71 plus 491 must equal 562. Only we can't just say it does and it becomes true. We have to actually add it. So I'm going to go over here and I'm going to write 491 plus 71 to see if I get that. I do. There it is, and it checks. Now you put your check mark and you're done. So those are the steps we're going to follow this entire time. Now, let's start with number 1. You're going to see that this x has a 2 with it, and they are together with multiplication. In order to get rid of it, we have to use its inverse, which is division. So we will divide with a fraction bar both sides by 2. Then we will show they cancel out. X is on the right. It doesn't matter which side x is on, but you should leave it where it began. 18 divided by 2 is the next thing we have to solve, which is 9. We're going to box our answer. That was one we already knew. We didn't have to do it over here out to the side. That's where our work should be shown if it's not something we can do in our heads. 18 equals 2 times, this is where we put this whole thing back here again and see if it really works when x is 9 like we say it is. So 2 times x, which is now 9, and that works because 2 times 9 does equal 18. Check mark to say we're done. It should look this beautiful every time. Find the x. Again, just like last time, we have multiplication, so we must divide both sides to get rid of what's with the variable. This is called isolating the variable, by the way, just for some handy vocabulary. Those cancel on the left, leaving us with x. 36 divided by 4 is 9. Now we have to do our check step to put this 9 in for this original equation to see if it does work. 36 equals 4 times 9. Sure does, and we're good. You should be following along, writing these notes down on your paper while I am teaching you. Number 3, now we have addition. The opposite of addition is subtraction. So we're going to subtract 9 from this side and subtract 9 from this side. It cancels on the right, leaving us with x. 17 minus 9 is 8. We're going to box our answer and do our check. Yes, indeed, if I put 17 equals x is 8 plus 9. That works because 8 plus 9 is 17. Let's look at number 4. We're going to divide both sides by 8. Both sides. And so there we're going to get x. When we cancel our cancellations, 56 divided by 8 is 7. 8 times 7 should equal 56, and it does. All right, we're going to get ready for number 5. These get really messy from here on out. I'm going to need a lot of space. I'm going to make my pen a little smaller so I can fit everything. That should work. So the opposite of plus, just like before, is minus. Minus 3 and 5, 6 from the left, minus 3 and 5, 6 from the right. We're going to cancel those out. X equals 8 minus 3 and 5, 6. This is borrowing with mixed numbers. So this is basically 7 and another whole to make 8. So if we borrow 1 from the 8, make it a 7, then we can add the 6, 6 here, so we can take this 5, 6 away, which is what we need to do. That will leave us with 1/6. 7 take away 3, that's 4. So we have 4 and 1/6 over here. Remember, all of this stays over here. It doesn't go in the middle of this space, which is like sacred space that we must keep clean. So we're going to box our answer. And we're going to do our check, putting in this x for this x to see if it does work. So we have to write the whole thing all over again the way it started originally to see if 4 and 1/6 plus 3 and 5, 6 really equal 8. My hope is they do. Now I got to add them over here to verify. Well, 1/6 and 5, 6 makes 6, 6. 4 and 3 makes 7, and that does equal 8. We have a winner. This is the way you'll be required to do equations all the way through high school. They'll get a lot harder, trust me. But this is the middle school format we expect to see on every equation you solve from here on out. This is a fourth multiplied by x, therefore we must divide both sides by 1/4 to cancel it out and get rid of it. They will go away over here because they're opposites, leaving us with 21 divided by 1/4. 21 is 21 over 1. Keep it, change it, flip it, and that will be 84. How do I know? Because 4 times 1 is 4, 2 times 4 is 8. That's going to be 84. I'm going to box my answer, and I'm going to do my check. So 21 must equal 1/4 of x, which is now 84. That does cross cancel, and so it works. Very good. Pause anytime you need to if I'm going too fast. For number 7, I have to get rid of a plus 2.17. So I need to subtract because that's the opposite of adding. They cancel, leaving us with x. 5 is really 5.0 minus 2.17, and we know to multiply or to add and subtract by lining up the decimals. That means I can add another 0 here, and I already had 1 0 that I added, so that I keep my columns lined up. Borrow from the 5, it becomes a 4. This becomes a 10. Subtract, and you get a 9. Give it to the 0, so that's 10. 10 take away 7 is 3. 9 take away 1 is 8. And 4 take away 2 is 2. My answer should be 2.83. We'll do our check so that we know for sure. If you really do a valid check where you make sure it works, you don't just say it works, you make sure it works, you will get minus 0 on every equation that you ever do, if you take the time to prove it. Okay? It's worth it. Why are you doing this work if it's not worth it? We have to get rid of a times 10 because this means that the 10 and the x are multiplied together. Therefore, we will divide both sides by 10. Whoa, that looks crazy. That's okay. 1/3 divided by 10 is really 1/3 divided by 10 over 1. We're going to keep it, change it, and flip it. Top times top and bottom times bottom tells us this is 1/30. Sounds weird. I don't believe it. Let's check it. 10 times 1/30, which is our x, should equal 1 over 3. It does, because 10 over 30 would equal 1/3. Or you can cross cancel and get it there. It is true, and it is equal to 1/3. Great job. Moving on. Let's look at number 9. Whatever's with the x is what we have to target to get rid of. The opposite of add is subtract. Again, this is sacred space. We must do our work over here so that we are not messing up this beautiful area. And it's because there's going to be a whole lot more steps. Right now you're doing one-step equations. I'm going to let you guess as to whether we're going to get to 2-step, 3-step, and multi-step equations. Yes, if not this year, you will in the future. So we have 17.05 and we must subtract 14.888. So just like it says, we're doing it right here. We're going to borrow because I can't take 8 away from 5. 7 becomes a 6, this becomes a 10. 10 becomes a 9, this becomes a 15. 15 take away 8 is 7, 9 take away 8 is 1, this is a 2. Our answer is 2.17. No, I did not try to make it the same thing as we had up here. Weird. Crazy. So we're going to do our check now. 17.05 back to the original equation, which is what it starts out with right here. We're going back to see if it works. It must equal 14.88 plus x, which we now said is 2.17. So we're going to see if it works. Just because I write it doesn't make it true. We have to add it here to see if we get the 17.05. Indeed. Okay, we did. Very good. Number 10, here we go. Almost done. So 3/4 times x means we must divide both sides by 3/4. Cancel over here. X equals 54 over 1 divided by 3 over 4. That's 54 over 1 times 4 over 3. Well, let's not even cross cancel because I'm going to have to divide to see if I can even divide these. So that seems like kind of redundant. I'm going to just multiply top times top. Again, I'm avoiding this space as it is my sacred space for doing all my equation work. I got 216. That would be my numerator. I'm going to go down here because I'm out of room right there. I'm going to run into my sacred space, which I don't want to. So 216 is top times top. Bottom times bottom is 1 times 3 is 3. You know I'm talking about the numerator when I say top and the denominator when I say bottom. 3 times 2 is 6, and my answer is 72. I don't know for real until I check it. 3/4 of that, 72, should equal 54. That's another stumper because I don't know if I could cross cancel here or what it would look like. So I'm going to go ahead and just do top times top and bottom times bottom and see what I get there. So 72 times 3, 216, and I'd have to divide that now by 4. I want it to equal 54. Guess what? It does! So I have a check, and all that work shows that I am correct. Make sure to ask lots of questions if you're not sure what to do, and get good because it makes everything easier.